In this video, we are going to discuss about the moment generating function of normal distribution. So, moment generating function is denoted by mx of t, which is equal to expectation of e raised to tx. So, on finding expectation of e raised to tx, we will get the moment generating function. So, that is equal to integral minus infinity to infinity e raised to tx into f of x dx. This is a general procedure to find the moments, isn't it? Same procedure is what we do in moment generating function also. So this is equal to integral minus infinity to infinity e raised to tx into 1 by sigma root to 2 pi e raised to minus x minus mu the whole square divided by 2 sigma square dx. So this is the PDF of the normal distribution. So I am going to take this constant terms outside, that is 1 by sigma root 2 pi is taken outside, minus infinity to infinity. What is left is e raised to tx into e raised to minus x minus mu the whole square divided by 2 sigma square is left, and dx. Okay. Now what I am going to do is I am going to give a substitution. So what I am going to do is I am going to give x minus mu by sigma is equal to z. So this is the general substitution that we give in normal distribution. And therefore x minus mu is equal to sigma z and x is equal to sigma z plus mu. Okay. So I can write this as 1 by sigma root 2 pi into integral minus infinity to infinity e raised to t into, I can write x as sigma z plus mu into e raised to minus z square divided by 2 d z. No. That is dx is equal to sigma dz. So sigma dz. So this sigma and this sigma gets cancelled. And what is left is 1 by root 2 pi integral minus infinity to infinity e raised to t sigma z plus mu t into e raised to minus z square by 2 dz. Here e raised to mu t is a constant since the integration is with respect to z. So we can take that term also outside. E raised to mu t is taken outside. Root 2 pi is already there, and minus infinity to infinity e raised to t is sigma z minus z square by 2 dz. So our exponent term was t sigma z minus z square divided by 2. So from this term I am going to take minus 1 by 2 outside. So if I am to take minus 1 by 2 outside, this term will be z square. Since there is no minus here, there will be a minus term. And since there is no 1 by 2 to take from here, it will be 2t sigma z. Now what I am going to do is, I am going to add and subtract a term. So I am going to add minus 2t t square sigma square, and I am going to add t square sigma square. Okay, so I have added and subtracted a term. So it is the same, isn't it? So this is equal to minus 1 by 2 z square minus 2t sigma z plus t square sigma square plus 1 by 2 t square sigma square. Isn't it? Yes. Therefore, I can replace that integral with this integral e raised to mu t divided by root 2 pi from integral minus infinity to infinity e raised to t sigma z minus z square by 2 dz can be written as e raised to mu t divided by root 2 pi integral minus infinity to infinity e raised to minus 1 by 2 z square minus 2 sigma z plus t square sigma square plus 1 by 2 t square sigma square. Isn't it? Yes. dz. So, this term doesn't have any z term. So, z variable. So, we can take that also outside. So, it is equal to e raised to mu t plus t square sigma square divided by 2 divided by root 2 pi. Integrating from minus infinity to infinity e raised to minus 1 by 2. I can write this as z square minus 2 sigma z plus t square sigma square. So, this is just like a minus b the whole square, the expansion of a minus b the whole square. So, I can consider it as z minus t sigma the whole square. Isn't it? Z minus t sigma the whole square. dz. Here, I am going to substitute z minus t sigma is equal to u. Therefore, dz is equal to du. So, I can write this as e raised to mu t plus t square sigma square divided by 2 whole divided by 2 pi into integral minus infinity to infinity e raised to minus 1 by 2 u square du. Isn't it? Yes. So what we have got is e raised to mu t plus t square sigma square divided by 2 divided by root 2 pi integrating from minus infinity to infinity. Integrating from minus infinity to infinity e raised to minus u square by 2 du. Now we can write it as e raised to mu t plus t square sigma square divided by 2 divided by root 2 pi into 2 into integral 0 to infinity e raised to minus u square divided by 2 du. Why? Because this function is an even function and integrating an even function from minus infinity to infinity is equal to 2 into integrating the same function over 0 to infinity. So, since this function is an even function, we get it so. So, we can write it as 2 into e power mu t plus t square sigma square divided by 2 divided by root 2 pi 0 to infinity e raised to minus u square divided by 2 du. Now what we are going to do is we are going to resubstitute. We are going to substitute u square by 2 is equal to v. So u square is equal to 2v and 2u du is equal to 2 dv on derivating the both sides. Therefore, u du is equal to dv. Therefore, du is equal to dv by root 2v. Isn't it? Yes. Because u square is equal to 2v and u is equal to root 2v. So, from this, we will get 2 into e raised to mu t plus t square sigma square divided by 2 divided by root 2 by integral 0 to infinity. We are going to replace this. C raised to minus v into dv divided by root 2v. So this is equal to this root 2, this 2 and this root 2 gets cancelled. So it will be e raised to mu t plus t square sigma square divided by 2 divided by root pi into integrating 0 to infinity e raised to minus v and v raised to 1 by minus 1 by 2 dv. We know integral 0 to infinity e raised to minus mx x raised to p minus 1 dx is equal to gamma p divided by m raised to p. So here we can write in this form of p minus 1. So this is equal to e raised to mu t plus t square sigma square divided by 2 divided by root pi integral 0 to infinity e raised to minus v into v raised to 1 by 2 minus 1 dv. So this is equal to e raised to mu t plus t square sigma square divided by 2 divided by root pi into gamma 1 by 2. We have already told in the previous videos as gamma 1 by 2 is equal to root pi, and this is a result. This is a result. Therefore, we will get this as e raised to mu t plus t square sigma square divided by 2. So this is the moment generating function of normal distribution.